Hey guys, today we're going to explore the idea of integrating exponentials. Now to do this, I want to go back and think about how we differentiate exponentials. Okay, so if we were being asked to differentiate e to the power of 2x plus 1, we'd be saying that first derivative is equal to, and we'd get the derivative of the power, so 2, and then we'd write out our exponential expression as it is. Okay, so hence we want to find the integral of 2e to the power of 2x plus 1. Alright, so remember integrating and differentiating, or the antiderivative, derivative, opposites of each other, right? They undo and redo each other, right? So if I've got those identical expressions there, which we do, so the integral of that, we must get back to that same initial expression. Alright, plus potentially a constant hanging off the back. Alright, just remember they're inverses of each other. Okay, and part 3 says find the integral of e to the power of 2x plus 1. Now, if we think about this process and think about what was missing from above, and yeah, it's that 2 sitting out the front there. Alright, missing. Alright, so if that 2 was sitting there, we'd end up with that exact same result from above, wouldn't we? Problem is it's not. Alright, so there is a little bit of a workaround. We can rewrite this expression with a 2 there if we say we're going to cancel that 2 by dividing by 2 on the outside of that integral. Now we know that this produces this. So what we've got is, we've got that times by a half. Now if you're thinking about what this means, another more unconventional way you could potentially write it is as so. Alright, meaning the same thing. A lot of the time though, we're going to be writing it with that half or a third or whatever it is going to be out the front. Alright, so there is a bit more of a generalised rule we're going to use from now on. This is leading us through into where it's come from. Okay, so let's try and do a couple of questions using this generalised rule. Okay, so we're going to find the integral of this expression, e to the power of 2x minus e to the power of negative x. Okay, so if I've got, just concentrating the first part, that e to the power of 2x, I've got 1 over that a value 2 at the front. I'm rewriting the exponential as it is. Now if I go and focus on the next part, this minus e to the power of negative x, I'm just going to put my minus symbol down. Now remember, it's still the same thing, 1 over negative 1 for that a value, e to the power of negative x, plus c. Okay, it's a little bit messy at this stage. Let's go and tidy it up. Okay, this is really minus negative 1, so it's going to be plus e to the power of negative x plus c. So just like differentiating exponentials, it's quite an easy thing to do once we get used to it. Okay, second example here is a find question, so we're going to be getting that numerical value. We've asked to find the exact area enclosed between the curve y equals e to the power of 3x, the x-axis, and the lines x equals 0 and x equals 2. Now all this stuff, the area enclosed by the curve and the axes and these two lines, that's all leaning on things that we looked at last lesson. But what's this new word creeping in here going to mean? Exact area. Yeah, it's going to mean leaving our answer in terms of e. Alright, so even though we could, we're not going to be putting this into our calculator and giving off rounded answers. Okay, let's do a sketch. Alright, so really good place to start. Give us a really good visual here. Let's draw ourselves our exponential curve. Alright, so this is y equals e to the power of 3x. Now we're enclosing this graph along the x-axis and the lines 2 and 0. Alright, so essentially we're going to be finding this area here. Alright, so let's go and set up our question, and we're going to integrate e to the power of 3x, which remember means we're going to get that a value, that 3, it's 1 over 3, The rest of it remains the same. And we're exploring or finding that area between 2 and 0. Okay, so now we just got to go and substitute, but there's one little trick to do before you go and substitute in this case. That 1/3 is a constant really sitting at the front. It's going to be applying to both substitutions, the 2 and the 0. So I'm going to advise we take that common factor out the front first, especially when we're leaving our answer in the exact form. And then we go and perform our substitutions for the rest of it. All right, so that's going to be 3 times 2 is 6, minus, same thing, e to the power of 3 times 0 is 0. All right, so we've just about got our answer in exact units. We're going to do 1/3 of e to the power of 6 minus, well, e to the power of 0 is 1 units squared. Okay, so I hope you enjoyed that lesson. You can now go and do your practice. That's exercise 4.3 on page 20 of your student workbooks. Remember, as always, seek help from your peers and teachers on Google Classroom.